Hello, and welcome to Summarize Science, where we break down the latest research. Imagine trying to build a tiny machine or arrange living cells into a specific pattern. To do this, you need to be able to move microscopic objects with extreme precision. One way to do this is by using a focused laser to create tiny currents in the surrounding fluid, which then push the particles around. This diagram shows the basic setup, where a laser is scanned through the liquid to generate these controlled flow fields. Previous methods were like trying to nudge each particle into place one by one, using a simple set of rules. But this caused problems when particles got too close, leading to unwanted pushing, traffic jams, and instability. In this new study, researchers took a much smarter approach using something called model predictive control. Instead of simple rules, they gave the computer a complete mathematical model of the flow fields. The system then runs thousands of random what-if scenarios to find the one laser path that will best move all the particles toward their targets simultaneously. To prevent particles from bumping into each other, they even added a personal space penalty into the calculations. As you can see in these simulations, without this rule, particles often collide, but with the new function, they navigate around each other perfectly. When they tested this in the real world, it worked remarkably well. But they discovered something fascinating and completely unexpected that the system learned on its own. They called it precision action at a distance. This graph shows that as the particles got closer and closer to their targets, the system automatically chose to place the laser path further and further away. Just like using a longer lever for finer control, moving the heat source further away creates gentler currents, allowing for incredibly delicate final adjustments. The new method proved its power by successfully arranging 9 particles into a tight grid, a task that was extremely difficult for the older, rule-based systems. This demonstrated a robust way to create complex, crowded arrangements without the previous instability issues. So, let's recap the important points. The researchers developed a new control system that uses a predictive model to guide multiple microscopic particles at once. This objective-based approach avoids particle collisions and instabilities seen in older methods. Most interestingly, the system autonomously learned that to achieve the highest precision, it should manipulate the particles from a greater distance. So, what does this all mean for the future? This technology opens up new possibilities in micromanufacturing, robotics, and even the life sciences. It could be used to assemble tiny devices, precisely position cells to study how they interact, or build artificial tissues, all with a new level of automated control and precision. Thanks for watching Summarize Science.